Hi, welcome to my project special.com. The paper you are looking for is Temporal Load Balancing with Service Delay Guarantee for Energy Cost Optimization in Internet Data Centers. Let's have a look on our abstract. In cloud computing services, Internet Data Center provides a major role in analyzing the data and optimizing the works. In IDC, let's have a look on our abstract. Cloud computing services are supported majorly by Internet Data Centers, which is also known as IDC. In IDC, the energy consumption increases rapidly based on the VM utilization. In this paper, the energy management problem for IDC is analyzed. In this paper, we analyze the energy problem management in IDC based on two design problems. In this paper, we propose a novel stage design and echo IDC algorithm to minimize the energy cost in IDC. The algorithm exploits the temporal diversity of electricity price and dynamically schedule workload to execute the IDC service through an input queue. Now let us have a look on our data flow diagram. First start the process, configure VM, then configure data center. After that initialize cloudlets. Then analyze input workload. Based on the input workload, check workload condition. If the condition satisfies, go to echo ID scheduler, or else give the workload input to workload shaping, shape the workload and give it to echo IDC scheduler. Then dispatch workload and estimate electricity price of the process. Now let's see the demo of our project. First we need to run home.java and source package temporal load. Click cloud environment now. So for cloud processing using CloudSim project, first we need to create data center, broker, virtual machines and cloudlets. So for creating these things, we need to first create data center. Give any values and click data center creation. So the 5 data centers are created now. It will show the data center name and number of machines used in that, host ID, number of PS, RAM and bandwidth for each and every data centers for their individual host IDs. Then we need to calculate broker. Now 6 brokers has been created successfully. Here the data center broker ID and broker name has been displayed over here. For each and every broker we have an individual broker ID. Then click next. After calculating data center and broker, we need to create VM. Click create VM. 8 virtual machines has been created now. Each and every virtual machine has its own ID and respective broker ID and MAPS value and RAM and bandwidth size for each and every VM. Then we need to create the cloudlets. Cloudlet instance jobs. Based on this cloudlet only we can able to process the remaining work. The cloudlets has been submitted to respective brokers. The cloudlet ID and its respective broker ID, then the length of each and every cloudlet and the file size and output size for each and every cloudlet. The file size and output size will be same for every cloudlet, but the length will be vary for each and every cloudlet. Then click next. we need to analyze the load of each and every virtual machines now. So based on the ID and VM ID and broker ID, we can able to calculate the load for each and every virtual machines. Then click next. Click input workload. It will analyze the input workload. The workload instance here is cloudlet IDs. Based on that cloudlet only, we can able to calculate the input workload. So after calculating the input workload, we need to calculate the admitted workload. Click shape workload. So it will calculate the admitted workload and check whether there is any possible to shape the workload or not. If yes, it will shape the workload. Then based on that only, it will calculate the workload ratio, whether any workload is dropped or not. Then we need to calculate energy cost. Click energy cost. Here first we need to identify the arrived workload, whether it is shaped or not. So after calculating the arrived workload, we need to extract the VM loads. So here the cloudlet IDs and its load, and it's VM IDs and its respective load. Then we need to allocate each and every cloudlet to the respective virtual machines and calculate the energy cost of each and every virtual machines. Click energy cost. So based on this, the energy cost has been calculated. So each and every cloudlet has been assigned to particular virtual machine. For example, 0 and 1 has been allocated, 0, 1, 2. All the 3 cloudlets are allocated to the virtual machine 2. Then 3, 4 has been allocated to 7 and 5 has been allocated to 6. Based on the input workload size, the virtual cloudlet has been allocated to the virtual machines. Apart from these 3 virtual machines, the remaining virtual machines are static and it has been shut down. Hence the energy cost has been calculated. Click performance evaluation. Here we can able to calculate the performance evaluation based on the total VM used, total VM and used VM and remaining VMs. That's all, the process is over. Thanks for watching my project.